How many kilograms of natural gas will a 145 megawatt natural gas electrical generation plant that is 34% efficient burn in a year? Oh dear. And that's a small one. Okay, so let's see. We're going to have to figure out the input energy for a year. Okay, so the first thing I want to do is let's figure out the rate at which energy is going into it, right? We know that it's coming out at 145 times 10 to the 6th watts or joules per second, right? But the input is going to be bigger than that, right? Because it's only 34% efficient. So efficiency is output over input. So therefore, input is output over efficiency. So that's going to be 145 times 10 to the 6th, and that's joules per second, right, divided by 0.34. So the energy is going into this natural gas plant at this rate. 145 E6 divided by 0.34. It's going into the plant at a rate of 4.2647. That's a 4. Times 10 to the 8th watts, or joules per second, right? Okay. So now let's figure out the energy in a year. Okay, so power is energy divided by time. So therefore, energy is power times time. So that is 4.2647 joules per second. And then how much time is it? It's got to be seconds, right? Notice we got seconds there. Oh, wait, this is times 10 to the 8th. Don't forget that factor of 100 million there, right? Okay, let's see. Okay, so let's figure this out, right? 365, whoops. That's days per year. Times 24 hours per day. Times 3,600 seconds per hour. Okay, let's see. Days cancels. Hours cancels. Right? Seconds cancels. And notice it will end up with joules per year, which is exactly what we want. Okay, so take this number on my calculator, multiply by 365 times 24 times 3,600, and I get just a butt ton of energy, right? The energy is equal to 1.3449 times 10 to the 16th joules, right? So that's the total energy input. And that's in a year. Okay, so now that we figured out the total energy input in a year, now we can figure out the mass. So energy is mass times specific energy, right? And this is natural gas, isn't it? Yeah. So we know that our mass is going to be the energy you want, which is going to be this, divided by the specific energy, right? So 1.3449 times 10 to the 16th joules divided by 55 times 10 to the 6th joules. Okay, we can do this. Divided by 55 times 10 to the 6th. And I get that the mass is 2.4453 times 10 to the 8th kilograms. And I guess if we rounded it to that place, we'd have to say 2.45. That's just an astounding amount of natural gas. But anyway, there we go.